Thanks for the intro, Mark. As Mark mentioned, my name is Mark Edwards. I'm a designer. This is Luke. Say hi to Luke. Look, show you got a Shea t-shirt.
The Android one.
Luke is an Android developer. Today we're going to be talking about using vector assets in your application. So this means for Android, that's vector drawables. There's a whole bunch of topics we're going to cover today, including what they are, how to create them, how to export them, how to use them, all the caveats. In fact, most of the talk is caveats because there's lots of issues of using vector assets. When we say vector assets, what we're talking about is actually shipping the path data. When you're normally creating assets, you'd be drawing circles and rectangles and other shapes. When we say vector assets, we're talking about shipping the creation vector data in the app so it can be rendered at runtime. This is sort of the normal way you'd be doing it on iOS and how you'd traditionally do it on Android as well, and even on the web a while ago, although you still kind of do sometimes. So this is shipping, this is a bitmap that's created from pixels. So they're quite different, and they both have different ways of that they need to be worked with. So in terms of vector assets, what are the benefits of using vector assets? Why would you do this over just shipping ping images or something else? For a start, they're a lot smaller, and that has other benefits. It means they load off disk a lot quicker. You only need one file. You don't need to generate a different image file for each device density. So obviously, anyone who's worked with Android a lot knows there's a wide range of devices, wide range of pixel densities. That's the same on iOS now. It's the same for the web. It's the same everywhere. When you use vector assets, you only need one file, or you can have multiples, but you really only need one file generally to support all the different resolutions. It also means you can have dynamic colors and do other dynamic drawing, which is pretty cool, especially with animation and other things that we're not talking about today, but it helps with that too. The files are really a lot smaller, so it's worth mentioning multiple times, although there is an asterisk, because there's lots of ways you can ruin that benefit if you don't create the artwork correctly, because again, you are shipping source files in your production bundle, so you'd have to be a little bit more careful. Images are a lot easier to work with. There are some drawbacks. You've got to be really careful when it comes to performance and memory usage. Luke's going to be better at describing it than I am. Generally, it's fine as long as you're using them for fairly simple uses. Again, we'll cover that. Just be really, really careful when you choose what should be vector and how you should use your vector assets. When we say vector assets, we're normally talking about working with SVGs, so that's scalable vector graphics files. It's a really old format. It's XML, well, old in computer terms, 2001, it's an eternity ago. They're XML files, and they contain all the shape and path data that we're talking about, as well as the styling information, what color they are. Incredibly popular for the web, as you probably know, and SVGs are, as we're about to explain, they're the way that you get to the vector drawable format. SVG2, I don't know if anyone's been following this. SVG2's been controversial. There's been a lot of backwards and forwards. It's not quite not settled on what the format's going to be and what new things are going to come with it. It's worth watching because there's going to be a lot of cool stuff happening at some point, hopefully, if they can get the working group and get their act together.
So, what are vector drawables? Vector drawables are an Android-specific vector format. Vector drawables support a subset of SVG's functionality. So Mark just explained before that SVG is like has a very long history, a very broad format, contains a whole bunch of stuff. With SVGs, Google's really just boiled it down to some of the bare essentials. They support groups, paths, and clip path elements, and transforms. I guess one of the main questions you folks out in the audience will all have is, if SVG is so great and it supports all these fantastic things, why does Android not just support SVG? Why do we need our own special format, which is vector drawables? This is because SVG is quite complex, and it does include a whole bunch of features. And trying to build and support a full SVG renderer that's going to run on a tiny little constrained mobile device is going to be a very difficult thing to do. It's going to use up a lot of CPU. It's going to use up a lot of memory, which we do not have a lot of. So with vector drawable, Google's really stripped SVG down to just the bare essentials and what's required. Here is an example of a vector drawable. This is what the file format looks like. And what we've got there, it's actually drawing the little Android guy logo that we've got on the right. let's walk through some of the key parts. And the first bit right up the top is this section, the width and the height. And pay attention to this, people. There is going to be a test on this part later. What this section does is it specifies the size of the image to Android. So if you put this image inside an image view and you tell Android to shrink the image view to wrap its contents, this is how big the image view is going to come out. The next section that we have here specifies a viewport width and a viewport height. This is actually different. This is the space in which all the following draw commands, the path commands inside the vector drawable file operate. It just so happens that in this particular example, it matches exactly with the width and the height that are specified just before it, but there's no reason why they have to be the same. And here we really get into the meat of the vector drawable file itself. You see there's a whole bunch of these path attributes. And the one that I've highlighted there is actually the one that's drawing part of the Android guy's head and the upper part of its body. And you'll notice inside the path data, it's got all these kind of commands and this special sort of language in here, which is something that Marc knows a whole lot about.
So it's very similar. Is anyone old enough to remember logo and turtle and yay, oh, awesome. We're all old. The actual path data is very similar to logo in that it tells the little cursor, the turtle, the pen down, pen up commands. There's move to a certain position, and I think these are the C, there's the control points for the Bezier handles, and if it's an uppercase M, that means an absolute move. If it's lowercase, that means it's relative. You don't need to know any of this stuff, but if you do want to hand code the path data, you can, or if you want to diagnose issues, it can be handy to know. So the big question is, when should you be using vector drawables? When should you be including vector assets in your app? Here's a hopefully simple explanation. On the left, we have action bar icons, that kind of thing, just single color glyphs. Yes, that's a great time to use it. They'll be tiny, they'll load off disk really quickly, they'll render quickly, no problems at all. In the middle, maybe, this actually looks super simple, but there is some clipping going on if you wanted to create this correctly with the correct anti-aliasing. Probably fine, depends. On the right, no way. If you've got an icon with lots and lots of shading, that's not a good candidate for a vector drawable. You should probably be using a bitmap. You should certainly be using a bitmap. And in fact, this icon, here's the Photoshop file. There's like 50 layers for the icon, and each layer has potentially layer styles and other stuff. So if you're talking about rendering, each one of those might be multiple buffers for each single layer. So it's not something you want to be doing on a mobile phone in real time. You're better off only doing it with the simple stuff. In fact, this icon even has some 3D rendered stuff, and it's 220 megabytes for the one icon file. So probably not what you want to ship in your app. You've got better things to do. In terms of creating assets, almost any design tool you're familiar with can do the job. Who's here is using Illustrator for this kind of stuff? Maybe? Yes, one. Photoshop, Sketch. Cool. Any Affinity Designer users? No? Oh, that's all right. You can use it if you want. In terms of creating the artwork, the best practices are to actually design at using a 1DP grid. So the Android system, when talking about rendering, the DP stands for density independent pixels. So 1DP can then translate directly to a certain number of screen pixels. So if the screens are, is it XHDPI is 2?
Yes, that's right.
MDPI is 1. Doesn't really matter. But basically, you want to use the 1DP grid, so that means that the artwork you're creating as a vector translates perfectly and aligns to the pixel grid of pretty much all the devices. There's some that have weird resolutions, but don't worry about them. You can't do much about it anyway. When you're creating artwork, you want to flatten or combine all the Boolean operations, so you end up with a single path. If you use any text, you should probably outline it, because I don't think vector drawables support text at all.
No, vector drawables do not support text, only paths.
There you go. So that's not going to help you if you've got text. And you also want to remove redundant points. Again, you're shipping the actual source vector data, so any optimizations you can do will help you. Whereas if you were shipping bitmaps, it doesn't matter, because it doesn't matter how complex the creation shapes were, because you're not rendering them on the device. In terms of using a 1DP grid, this is what I mean. So hopefully you can see the grid lines here. There's some icons that have been drawn, and all the main points or the edges of the curves all aligned to the pixel grid, and that means on all the devices they'll look nice and sharp and crisp, which is important. And in terms of flattening and combining shapes, this icon could have been created using a whole bunch of different shapes. In terms of production assets, what you want to do is really just turn it into a single path, because it just makes it more optimal when rendering on the device. And again, uses less memory, faster performance, it's good. In terms of flattening and combining paths, in Illustrator that means using the path finder to create the combined shapes. In Sketch, that's under the layer combine flatten menu. This might also mean you might want to have two copies of your assets. You might want to have one copy that is the editable assets that you're working on, and another copy that is the production assets that actually get shipped in the app. Yeah, in terms of text, if you've got any text, outline it. All the design tools I mentioned have a way to do that. You want to ship an actual path if you did need to have text in your icon. In terms of removing redundant points, this is a good example of something you probably shouldn't ship. A circle can be created with 4 points, so that's going to be more optimal when it's rendering on the device. And Illustrator's really good at doing stuff like this. This is just the brush tool. You can just freehand some text and style it like that. I don't know what that would do to a device. It probably wouldn't be pretty. It would probably crash the app instantly. So you just need to be really careful on choosing which assets you create using vector graphics, and also when you create them, you have to make sure they're optimal. In terms of exporting, what you're really looking for is to try and build a workflow that is as automated as possible, because that will help you reduce errors and also it'll make it less effort to re-export. So if you need to make changes, you'll be more willing to make changes. You actually make a better product because you're happy to make changes because you've got it all automated. This is what I call a sticker sheet for one of our apps. And this actually doesn't export vector graphics, but it was the neatest one I had to show on a slide here. So this is actually for images for pings, but this is how I usually set them up. And it's all automated exporting. So that means if you need to make a change, you make the change, one click, you've got all the assets. So you definitely want that to be part of your workflow. When you're exporting, if you're using Illustrator to export, I'd recommend using artboards and the new export for screens feature. Illustrator has a 100 artboard limit, which can be a real issue if you're trying to build a big library of vector graphics and export them in an automated method. But yesterday I found out Illustrator, the next version is going to be 1,000 artboards, so at least that makes that a little bit easier. If you're using Photoshop, you can use artboards or groups and export using export as or generator. Generator is an old method that isn't very well supported. I actually recommend not using Photoshop for creating SVGs. It does a pretty terrible job. Although if you use it with paint code, it's awesome. And we'll talk about paint code later. And for Sketch, there's really nothing too revolutionary here to talk about. Sketch is standard, make exportable method works really well, and the SVGs are pretty good. And Affinity Designer, even though no one's using it, it actually produces amazing SVG results. So it's, out of all the testing I've done, the Affinity Designer results were actually the best. So it's pretty cool. If you were going to use it, you just have to export using the export persona and slices as you normally would for Affinity Designer.
So your designer your very talented designer, internationally renowned, has given you a zip file filled with beautiful, handcrafted, locally sourced artisanal SVGs. But now, as an Android developer, we've got a problem. How do we convert those SVGs into vector drawables? Because as we know, there are lots of things that the SVG format supports that the vector drawable format can't handle. And there are a couple of different ways that we can do this conversion process. For simple icons, really very basic stuff, it's not really going to matter how you do the conversion. All of the tools are going to work with them. But if your SVG is at all complex, you may run into some issues. And what do I mean by complex? In our experience, there are a few SVG features that can cause issues with the conversion from SVG to vector drawable. We have got clip paths, which are used to subtract one shape from another. We have inner and outer strokes, which are actually a feature of a number of design tools that have no equivalent in SVG, so there may be some fidelity issues that you run into during the export. We have gradient fill, which is a new feature supported in Android 7's vector drawables, but is not supported in the earlier versions. This thing called a fill rule, which actually caused all kind of problems for me when I tried to use vector drawables. And it's to do with how the insides of shapes are actually filled or left empty.
We can talk more about this at the end, but it goes into a lot of detail that you might not care about, but it's good fun. It can cause a lot of problems though.
Again, this is something that Marc knows all about. The other thing that causes difficulties is transforms. They're pretty obvious, like rotate, scale, skew. And lastly, SVG format has this attribute that you can add up at the top of the SVG file called the defs section. And in there you can define reusable parts of your SVG file. In particular, a lot of tools use it for putting in styling information, which gets embedded in that def section using CSS, essentially. There are 4 different tools out there which can convert from SVG to vector drawable. And we're going to run through them quite quickly. The first one, the most obvious, I think, as Android devs, everybody knows this one. It's Android Studio. It supports import of SVGs. You right-click, go to New, Vector Asset, and it brings up this tool that's able to import either one of Google's pre-built material icons, or you can import an SVG or a Photoshop image. SVG to Android is a web-based tool that can perform the same conversion for you. The really nice thing about this particular tool is it supports multiple files at once, which is great if you have like several hundred SVGs that you've got to go through and process all at the same time. It also supports some nice options for dealing with some of those problematic things we saw before, such as transforms and clip paths. This one is a mouthful, so I've got to prepare myself. SVG to vector drawable converter.web, as you may have guessed from the name, is a web-based tool. This one only does one file at a time. It does have lots of options that you can see here in the drop-down menu, but I searched around and tried to find out what they actually do, and there's no documentation of them or what they actually mean. One good thing about this tool, though, is you notice like the .web in the name. There's actually a command line version of this as well that you can download and use on your computer. So if you wanted to set up some sort of automated asset pipeline where you can convert directly and automatically and get vector drawables out at the end, this tool may be very handy. Lastly, we've got paint code, and paint code's a really interesting one, actually. It's a fully featured image editor, and the main point of paint code, the reason it was created, was so you can draw a whole bunch of things within it, and it'll actually generate Java code or Swift code that you can then include in your app that will draw complex parameterized images. However, for what we're covering today, it's got one helpful little feature which is sort of like off down to the side in one corner of the app. It actually supports native vector drawable export. So you can use that as a conversion tool, or alternatively, as Marc mentioned before, you can actually go directly from Photoshop into paint code, and then you can skip the SVG step entirely.
It's pretty good. It actually does. It's an amazing job on a very old, weird format. I've found that to be probably one of the best ways.
We decided to put all of these tools to the test with a number of SVGs that Marc handcrafted to include all of these problematic, difficult elements. We've got clip paths, inner strokes, gradients, fill rules, transforms, and a bunch of them include styling information inside the def section. This actually turned out to be a surprising amount of work. There's 5 different SVGs, 4 different tools. I tested them across a bunch of versions of Android, but fortunately, I found a way to get through this in record time. I had a very productive afternoon, and here are the results. And the first thing that I guess everyone's going to notice is that pretty much everything choked on trying to convert a SVG that contained gradient fill, which is not surprising because even though Android 7 supports it, there's like practically no documentation on what it actually is and how to make it work. And I was trying to find, I couldn't even work out myself how to handcraft an SVG that includes a gradient inside it. And I saw yesterday, actually, somebody tweeted like some code that does it, and I'm like, oh wow, so that's how you do it. That's how it's supposed to work. Great job, Google, on the documentation there. Android Studio, you can see, obviously had some pretty serious problems on those vectors that included the styling information in the def section. This is a known issue. Apparently there is a bug fix coming soon that's marked as fixed in Google's Android Studio bug tracker, so keep looking for updates, that may get better. SVG to Android actually worked pretty well. The only thing it had any troubles with was dealing with the transform. But if we listen to Marc's excellent advice, this may not be an issue. We can get SVGs without transforms, is that correct?
Yeah, so if you take the step I was mentioning about flattening all the Boolean operations and flattening the paths, essentially what that does is it resets the transforms anyway. So what you end up with is normalized path data, and it just doesn't matter. You just don't end up with transforms in the SVG. So yeah, that's one good solution.
SVG to vector drawable converter.web had a number of issues apart from its terrible name. You can see that it had some problems with the inner stroke one, and the fill path thing got a little bit messed up. And lastly, we've got paint code. Apart from the gradient drawable, which nobody at all supports, paint code worked really, really well and gave us some really good conversion there. Therefore, based on all this, we recommend using paint code. It does cost $99, so if you don't have a copy or you want to do bulk import, then SVG to Android comes as a close second, particularly if you've got a nice clean set of SVGs. The other thing absolutely everybody should be doing, regardless of whether you're using SVGs or not, is keep checking Android Studio for updates. Reading through the tea leaves of Google's bug tracker, there's a bunch of new features for the SVG import in Android Studio that are coming down the pipeline, and it's looking like they're going to improve things significantly. So now we've got vector drawables. It's all downhill from here, right? It's going to be really easy to include them in the app and get them showing up inside Android, right? Do you reckon this is going to be easy?
My part's done. It's up to you.
Well, what do you folks think in the audience? This is going to be simple and straightforward, right? There is still 21 minutes left on the talk, so... Again, there are lots of options for how we can do this. There's actually 3 different ways that we can display SVGs inside our app. So let's run through them all. The simplest and the first and most obvious way of showing SVGs in Android is just to use the native vector drawable support that came along in Android 5. It's really simple and straightforward. Once you've got your vector drawable XML file, you just copy it to the res drawable folder. You can reference it inside your XML code like you would reference any other drawable in there. There are a few caveats that we need to be aware of with this. Android 7 has support for some new vector drawable features that you may find yourself in need of. And the other thing is when we tested this, there's a bunch of different bugs in Android 5 and Android 6 to do with the way it draws and renders vector drawables. One really cool feature that is very nice about using native vector drawables is you can use an @color reference inside your file. This makes it really easy to use your application's branding and colors inside your icons. It also means you're using a consistent set of colors, which will make your designer very happy, correct? There's no possibility of accidentally using a slightly wrong shade on something or messing something up. It also means that if you decide to change your application's colors and the branding and the business comes back and says, look, we've decided to go for a slightly different shade of red, instead of the designer having to rebuild 200 different assets and you've got to include 200 different new assets, you change the color in one place and it gets updated across everywhere. One thing that did come as quite a shock to me when I started investigating native vector drawables is that it turns out vectors are not always sharp. They can get pixelated, which is kind of shocking. The entire reason of vectors is so that we can get sharp, beautiful images. It's how Marc sold it to you on the very first slide we showed. They're going to be sharp. But unfortunately, there are a few issues. Remember, I pointed out a section of the vector drawable format right at the beginning and said there's going to be a test on this later, folks. Well, here it is. Here is the test. You'll see I've highlighted here the width and height which are setting this vector drawable to be 24 dp in size. And here's that vector drawable shown in Android. It may be a little bit hard to see clearly all the way down the back, but I assure you, these things are pixelated and blurry. This is on Android 5. And the reason they're pixelated and blurry is inside the top of that file, it says that that vector drawable is 24 by 24 dp, but we're actually displaying it in an image view that is 100 by 100 dp. And what Android 5 is doing is it's rendering it to an internal bitmap that's 24 dp wide and high, and then it scales up the bitmap, so you get all these huge pixels and it comes up blurry.
If anyone's used SVGs on the web and used CSS transforms for scaling, it actually does the same thing where it renders it at the original size and gets blurry. So yeah, you have to be careful with that on the web as well.
Fortunately, this isn't an issue in Android 6 and 7. Google's fixed it up. So here we see exactly the same stuff showing on an Android 7 device, and it is almost crystal clear. There is one little further caveat. If you want your vector drawables to be absolutely pixel perfect, you need to follow the advice that Mark gave you earlier about making sure they align to a 1dp grid. If anybody wants to come up super close to the screen and stare at this thing, you'll see that there's a couple of pixels that are wrong on this one particular drawable there, which is because Google hasn't followed Mark's advice and haven't set their things to 1dp grid. If you have to support older versions of Android before Android version 5, which I think probably still, unfortunately, a lot of people in this room would have to do. A lot of people I know still have to build apps that support the Android 4 series or Android 4.4. And you want to use vector drawables because vector drawables are awesome. It's actually quite simple. All you need to do is set your min SDK version to something below 21. And what Gradle will do is it'll automatically generate PNGs for you, which will be included in your APK, and they'll be used to support old versions of Android. This comes with some pretty major caveats though. Firstly, this Gradle generation of PNGs, it doesn't even support all the features of vector drawable. So we've got SVGs that has all these features, and then you've got vector drawable, which is a subset of that, and then you've got the PNG export, which is an even tinier subset of that. Secondly, remember how I was saying how cool and awesome it was that we could reference our applications at colors from inside the vector drawable files? That does not work. You will get a compile error if you try to use Gradle's automatic generation of PNGs. Here's how the PNG generation actually works out in a real example. We've got an app that includes one vector drawable, and on the right we've got the contents of the APK file. And I think the first thing to notice is that we've got the PNG, which is in a folder prefixed with V4, which means it's going to be used on the earlier versions of Android. And then we've got the vector drawable itself, which is in a folder prefixed V21, so that we can see on the newer versions of Android, it'll be loading up and displaying the SVG, and on the older versions of Android, it'll be going back and using that PNG for us. The last option to support drawing vector drawables in Android is to use the support vector drawable library, which is a backwards compatibility library that Google has provided. Essentially what it does is in Java code, it extends the drawable class and provides a class called vector drawable compat. And what will happen is if you use this library on versions of Android before version 7, it's going to use vector drawable compat code. On 7 and above, it's just going to delegate down to the native implementation. And the reason for this is that it allows us to use features of vector drawables that are only present on Android 7 and above. And it fixes a bunch of issues in there, including the problem that we've got with vectors not being sharp on all API levels. So if you use the compatibility library, that is solved for you. The other nice thing that compatibility library allows us to do is it allows us to, once again, reference our colors.xml values from within the vector drawable. Here's how it all actually looks. Quite straightforward to set up. We need to modify our build.gradle. We add a line that says we want to use the vector drawable support library. We reference that support library, and then we're off to the races. All we have to do inside our in our activities is make sure that they extend app compat activity. And what we can now do is when we have an image view, we use this app::source compat attribute, and we're able to reference a vector drawable inside there. Great, right? Well, almost. Displaying vector drawables inside image views is a lot of what we want to do as developers, right? We've got an image, we want to put it inside an image view, yeah? But there are a couple of other places out there where we might like to use vector drawables, and these are not supported out of the box by the app compat library. In particular, if you think about like text views in Android, have like a drawable left and a drawable right attribute that you could reference a vector drawable in. Elements have a background attribute we could use. We can do like layer list drawables that are going to reference other drawables. And none of these things are going to work out of the box with the app compat library. In fact, they'll cause your app to crash. So if you're part of like sort of the happy majority, the 90% case where you really only want to show some images inside image views, this is going to be fine. If not, you may run into issues. Fortunately, Google have given us a magical setting to turn on, which fixes all of these problems. If you call app::compat_delegate.setCompat_vector from resources enabled true, what is going to happen is it's going to enable some magical extra backwards compatibility code that will mean you can reference vector drawables anywhere. So you don't need to worry about these small caveats at edge cases. And you can see there what I'm actually doing is we're referencing a vector drawable from the drawable left attribute. Beware though, if you read the documentation for this method, it comes with all kinds of terrifying warnings from Google why you may not want to use it, including additional CPU usage, additional memory usage, problems when the telephone is rotated and the configuration changes. So really, this is not something you're just going to want to turn on by default willy-nilly. It's something that you're going to consider. Is this an issue that I'm having? Is this something I'm going to need? And then enable it and see what impact it has. But I guess you folks really don't want to go too far into all the intricacies of the 3 different types of rendering vector drawables. You just want to know which one to use, right? And our recommendation is support vector drawable. It makes sure that your vectors are sharp on all versions of Android. It includes support for newer features of vector drawable and bug fixes. You can reference colors from your XML file, and it also helps future-proof your app. Because if there are bug fixes or performance improvements, you just have to change the version of the library you're referencing and you automatically get all of those. There is one small additional bit, and this is if you are targeting only the very latest and greatest versions of Android, which unfortunately is not a lot of us, you may be able to get away with just using straight old plain native vector drawables. So we have been talking for quite a while. And we've covered a lot of complex ground and gone through a lot of difficult and simple things. So what we want to do at the end is try and boil it down to a simple, straightforward process for you folks to use vector drawables in your Android apps and get a good result. If there's anything that you come away and remember from our presentation today, it is going to be the next 4 slides. These are the ones you want to take photos of and tweet about. So with that, I will hand over to Mark to explain how to create clean artwork.
Yeah, so the most important points are snap everything to a 1 DP grid, which means it'll scale up for all the different device densities. Flatten all your paths, get rid of all the Boolean operations so you end up with one clean path or the cleanest representation of the icon that you're trying to build. Again, for production, you may want to keep separate assets for the actual ones you edit. If you use any text, outline it, and just remove any redundant points that you might have in the artwork, because again, you're shipping source files within the bundle. It's not some bitmap representation of it. It's how it actually has to draw it on the device. In terms of exporting, you can use pretty much any tool you want, but you just have to be a little bit careful about the techniques used. So again, Illustrator used the new export for screens. That gives the best SVG results. Sketch just use the standard. There's only one export method anyway, so just use the one that comes provided. Affinity Designer, again, only one method. Just use slices. They're great. Photoshop, don't use Photoshop for creating SVGs unless you're also going to use paint code. The Photoshop SVG output is a little questionable. It's not so great. I've done a whole bunch of tests. I've decided to never use it ever again in my entire life.
For converting those SVGs over to vector drawables, use paint code. If, for whatever reason, you don't want to use paint code, use SVG to Android. And always be clicking on that upgrade button in Android Studio, because any day now, upgrades are going to come to that SVG import process inside there, and everything's going to be all sunshine and rainbows. Lastly, to display your vector drawables inside your Android app, use the support vector drawable library. It's got the least trade-offs of all the approaches. If, and that is a very big if, you're only supporting the very latest versions of Android, then perhaps native will work. So I hope you folks have a lot of success following the Marc and Luke 4-step vector drawable plan, and I believe we've now got some time for some questions.